Hello everyone, and I'm starting off our presentation of our project, which is digital voltmeter using 8051 microcontroller. Okay, let me tell you about the voltmeter and digital voltmeter. Okay, a voltmeter measures the voltage or potential difference between points in electrical circuits, and traditional analog voltmeter actually uses needles, and actually or a digital voltmeter convert the input into a digital value and display it numerically on a LCD display. And let's go to our block diagram. Okay, we start with the block diagram, and we use 8051 microcontroller, ADC 0804 analog to digital converter, and a 16 cross 2 LCD display, a voltage divider, capacitor of 150 picofarad and 10 microfarad, and resistors, power supplies, and etc. connecting wires. Here is the working video of a digital voltmeter, and we use a 16 cross 2 LCD display. It displays the process data, and LCD uses actually liquid crystals that align to control light passage. Control via digital commands from the usually 4-bit or 8-bit mode from the microcontroller. The controller HTD 44780 for communication with the microcontroller. Here is the 8051 microcontroller acts as a brain of the system and reads the data from the ADC and processes it and sends output to the LCD display. The tech behind it is actually it's an 8-bit microcontroller built within memory, I/O ports, timers, and serial communications. Handles the real-time controls the task actually. And here is the ADC 0804 analog to digital converter, converts the analog input into digital data, and the 8051 can understand. Actually, the tech behind it is 8-bit ADC with a single analog input and digital output. It uses successive approximation method to perform the conversion. It needs a clock signal and reference voltage to work actually. And this is the flowchart diagram of our project. And the physical quantity from the voltage is taken to the sensor, and the sensor converts to the electric signal, and the electric signal goes to the ADC and converts to the digital and goes to the microcontroller.
Hello guys, this is Nuclear Engineer. I'm going to be explaining about the working and the implementation of the voltmeter using 8051S52. The work connections. The connections, so basically the LCD is interfaced using the port 3, and port 2 is used for the data pins of the ADC, and the control pins connected to the port 1. We didn't use port 0 because it needs a pull-up resistors, which is like more components, which if you have a resistance box is convenient, and we did not opt to that. And we used a potentiometer to set the contrast for the LCD, and we use an RC circuit to power this thing. And now let's go ADC. Now the voltage sensor is 2 jumper wires as the probe, which can be changed if you want a better accuracy, but for our case we have maxed out to 25 volts because we didn't want this to be unreliable, so we have just maxed it out to 25 volt. We can make it more complex and get more than 25 volts accuracy. So both are the same here when it comes to voltage, so there's nothing to change here, but we can consider it as this is the structural the functional block diagram, the input voltage digital voltmeter display. Now once the reset pin is set, it will display digital voltmeter, and then it will go to the calculation part and then display it to the LCD. Now if you want to repeat it, you can put it in an infinite loop and just calculate the value continuously and display it. But what we have done is just display it once and leave it at that, so that if you want to know another change of value, we have to press reset again, which will be shown in the video that we have shot. Now this is the code which will be given in the description below to check and further work on. Now this is the video demonstration of this circuit, and as you can see it's 0.0 volts right now, and when we connect So when we connect the probes across this voltage divider circuit, which is using 222k resistors, to divide it 50% 50%, and to get the, to see how the values changes. Now as you can see, the voltage is now 0.0, and now once we reset it after connecting to the divider circuit, it's 7.8 initially. And now if you actually remove it and change the position of the positive probe into the middle of the division test circuit, we will get once again we are going to actually press the reset button, and we are getting 3.1 volts, which is approximately half of the previous one, which is not accurate. But changing the probe, that is the jumper, might help with the accuracy and other connections.
Hello everyone, I'm Bharat Vaishnav. I'm going to explain the code for a digital voltmeter. First, in this project, we have defined the LCD data pins in port 3, and we have connected the data pins of an ADC in port 2. LCD has been connected with a 4-bit mode, while all the 8 data pins of ADC has been used. First, we have defined an ADC function which sets the right pin of an ADC as low and sets read pin of ADC as high. Then, as long as the interrupt is 1, it waits till the conversion of the value is over by the ADC. When interrupt becomes 0, the read pin is set to 0, and the converted value is sent to the microcontroller. Standard delay function has been defined so that the signals produced by the ADC have time to settle. The LCD in this project has been defined in a 4-bit mode, and the display also works in a 4-bit mode. So each first nibble of data is taken by the LCD from the microcontroller. Then another nibble is taken so that it joins the both nibbles together and displays the data. Next, an initialization function is defined where 0x02 and 0x28 says that the LCD has been initialized in a 4-bit mode, and 0C and 80 represent that the cursor is on, and the LCD, the cursor starts at the 0th position in the first line. Then in the introduction function, the LCD is made to display the string digital voltmeter. And then when we come to the main function, first the initialization function of the LCD is called to initialize the LCD. Then the introduction function is called to print the string digital voltmeter. Then the values produced by the ADC is taken and stored into a variable known as data. Then data is multiplied by 0.02 because 0.02 is the resolution of the ADC. The step value of an ADC can be calculated by finding the maximum Vref and dividing it by 255. In this project, we have used 5 volt as the reference voltage, and if it's divided by 255, we'll get 0.02. Then the value we get after multiplying the data by 0.02 is divided by 0.2, as we have used a voltage divider network to reduce the voltage which we get from ADC to less than or equal to 5 volts. Then after we have reduced it to a voltage less than 5 volts, the voltage, the value we got from ADC stored in the variable val, which is then converted into an presentable form, such as if value get from ADC is 87, this data will be converted into 8.7 while representing the voltage in the LDC.